What are REST APIs? In this video, you're going to learn everything you need to know about REST APIs. We're going to be covering what are REST APIs, why they are used, and how to design your own REST API. By the end of the video, you will not only be able to create your own REST APIs, but I'm going to show you a really cool way to easily manage them. By the way, if you're new to my channel, hi there. My name is Yusuf and I'm an IT consultant and part-time YouTuber based in Hamburg, Germany. In this channel, I share all the valuable knowledge that I have learned in the last years to create clean and modern software. This includes things like free condensed courses, React code reviews, and also advanced coding patterns. And if there's one thing you can't go without in modern software development, no matter if you're a front-end, back-end, or full-stack developer, that will be REST APIs. So what are REST APIs? Before we dive into REST APIs, we need to learn what are APIs in general, because a REST API is just one type of APIs. So API stands for Application Programming Interface, and the keyword here is interface. And the simple example of an interface would be a TV remote. So TV remote has some buttons, each for a specific function, to turn on or off, to adjust the volume, or to change the channel. Notice that each button says what to achieve, but not how to achieve it. So it doesn't matter what kind of TV you have, when you click on, you expect it to turn on, no matter if you have an LED TV or a plasma TV. And that's the same thing in programming. An API just defines what a program or a system does without really going into the detail how it internally does it. It doesn't matter what programming language is used or what kind of database, it just defines what a system can do. Now here are some examples of how APIs look like in the real world. Let's say that you have a weather app. So every time that you open the app, you want to get the current weather. Now in order to achieve this, you need to somehow get the weather data from somewhere. And in this case, it's going to be a server with a database where all the weather data is saved. And every time that you open the app, you can get the data from that server. So the server will have the following functionalities. Get the current weather, which returns the weather of the current city name, or get a forecast, which returns the forecast of the whole week for a given city. And maybe that server will also have the functionality to have alerts. So given a specific region, it can return a list of alerts like high wind conditions or something like that. And this is always very specific to the use cases of the application that you're dealing with. Now, REST just builds on top of that. So REST stands for Representational State Transfer, and it's just a way for applications to communicate over the internet using the HTTP protocol. So here's a breakdown on how it works. So every time that a client makes a request to the server, it needs to define a few things. First, you need to define a method or a verb, and this specifies what action you actually want to do. Get is for fetching data, post is for creating new data, put is to update data, and delete is of course to remove the data. And then you have a path, and this is the resource that is accessed, for example, /users or /product ID or something like that. And then you also have a list of headers, which are extra information that you can pass for authentication, for example. And when you want to update the data on the backend, you also pass in a body, which is just the data that you want to write on the server. And once that the server receives your request, it's going to process it and then send you a response. And the response is made out of a status code, an optional list of headers, and optional body. So the status code is just a number that represents if the request has been successful or not. So if the server answers with a 200 or 201, this means that the request was successful. If the server answers with a 400 number, like 401 or 404, this means that there was a problem with the request. For example, some invalid data has been passed. And if the server answers with a 500 code, this means that there has been some kind of error on the server. And then there is a response body, and this can be anything from an object in JSON format to an HTML web page. Now, if we go back to our examples, we can define a REST API for them. Getting the current weather, that would be a GET request, and the path could be something like /weather, and then you pass in the city as a parameter. For getting the forecast, you can also have another GET request, /forecast and also pass in the city. And if you have something like getting the alerts, you can have an endpoint for that, and that would be /alerts, and you pass in the region as a parameter. Now this is all good, but I think you learn the most when trying to implement stuff yourself and not just learning about theoretical things. So let's get down to a real life example. So what we're going to be doing here is try to create an API specification for the backend of this application that I have been building in my previous tutorials. And this is just a phone book application where you can save your contacts with their addresses and phone numbers, and you can look them up. You can also create new contacts and edit existing ones, and also delete contacts. So let's go ahead and design an API specification for that. Now, before we go and design this API, you're probably already wondering, how do you actually write this down? Should we just create a text document and write everything down and then send it to every developer? That way they know how to communicate with each other. Or is there a better way? And of course, there's a better way. Otherwise, I would have asked this question. And that is this OpenAPI specification. And I said OpenAPI and not OpenAI, just to get that confusion out of the way. And the format is actually very simple. In the top, you have a section for the metadata. So the title of the API, maybe some description, and a version of the API. And then comes this components part. And here you can define the data types that you want to use throughout your application. I'm going to come back to this later, but here you just define how objects look like, and that saves you a lot of writing because you don't have to copy and paste stuff. And then we have the major part, which is this paths part. And here you can see, for example, /contacts, and then there's a get method. You can define which kind of parameters you have or what you expect in the request body and how the responses look like. And then we have some other information about the servers that are available. So here you can have your production, development, and local server, for example. Now, the cool thing about this format is that it's very generic, so you can use it to, spoiler alert, generate front-end and back-end code from this file. But I think I'm getting ahead of myself. Let's go ahead and first try to design our API. Now, you're probably thinking, do I have to write everything down like this? This looks like a lot of work. I would rather just skip this. And luckily, there is another way to generate this file, and that is using an API client. And for that, we're going to be using Echo API. So we have this phone book application. So let's go ahead and design the REST API of a backend server that can be used with this application. So it's really helpful to just go in step by step and try to figure out which use cases we have here. And here what I'm seeing in the first screen is a list of contacts. And then we have some pagination. As you can see, we also have 5 pages, so that's also something that we need to know. So let's go ahead and open Echo API, which is an API client. It's really cool. It's actually also sponsoring this video, so thanks for that. And go ahead and just click on Create New HTTP. So we need a list of contacts. This is going to be a GET request, and this can be /contacts. So this is going to be our get contacts endpoint. So I'm gonna call this get contacts and with pagination. So in the design tab, when you scroll down, you're gonna see that you have a predefined response. And here we have our data schema. And here we can define what do we actually expect to receive as data from this endpoint. So here we have an object, and we can add in some fields. And let's call the first field contacts. And this is going to be a list of contacts. So let's change the type to array and confirm. And of course, here we can have our items, and the items are going to have the type of object because each contact has multiple fields. And here we can then add the field. So we're going to have our first name and a last name, and also maybe a contact ID that we can use later on when we want to look up the details of a contact. Let me just correct this, contacts. Now we also want to have some information about the page that we're currently in and how many pages we have. So let's go ahead and add another field here on the top level and call this pagination. And this is of course also going to be an object, and this is going to have multiple fields. For example, current page and total count of pages. So total pages, and these are both going to be numbers. Nice. And we can also add descriptions if the fields are not specific, but I think contacts and pagination are clear enough. Of course, we want to get contacts by page, so we need to somehow also add the current page to the requests. So if we go into the request, here we have parameters, and let's just pass in a new parameter, and let's call this page, and it's going to be a number. And you can see on the top that we have our page parameter appearing in the URL. And if I go to debug, then you can already make a request if you want. You can pass in, for example, in the parameters, you can set the value of 1 and then it updates in the URL. And if we have a server running in the background, you can click on send and see the response. Great, we have our first use case, which is get all contacts. Now, when you click on a contact, you're able to see the details. So we need a new endpoint for that. So let's just go ahead and do the same thing. And this time it's going to be a little bit different because we're going to have a path parameter. So we go to the design tab, and this time it's going to be /contacts/ID, which is the contact ID. And this is a path parameter, which means that it has to be given here. And if you don't give it, you're just going to be in the other path, which is get all the contacts. And this is going to be a string for now. So here we're just expecting a contact object. So let's just add a new field, call it contact. And this is going to be an object, confirm. Now we can either write the stuff manually again, like we did in the other endpoint. But since this is getting repetitive, we can actually create a data model. I'm going to bring back the sidebar, and here we have in schemas. I already have a user type that I used in the previous example, but let's just create a new schema. I'm going to call this contact, and then we can put in everything that we wrote before. So this is going to be an object with first name, last name, an ID, and let's also add in the address and the phone number. So address and phone number. I'm going to put in the ID in the first. Let's write the model name here, contact, save. Now that it's up here, we can go back to our API. So now instead of having a contact object, let's remove this and add a new field and reference data model. And this is going to be of type contact. And you're going to see that everything is filled out for you. And if you ever change the contact type, then it's also reflected on all the endpoints. Now we can see the list of our contacts. We can also see the details of every contact. Let's go ahead and add this add contact functionality. And as you can see here in the UI, the user will input the first name, last name, the phone number, and the address. And all these fields are also going to be passed as a parameter. I'm just going to duplicate a route, and this is going to be a post request and not a get request to contacts. And post is also actually always used when you're creating an entity. So in the design tab, we have here this predefined response, which returns a contact that works perfectly. I'm just going to adjust this to a 201, which means created. You can also use a 200, but 201 is very common when you're having a post request. And here I'm just going to choose a raw data type and choose JSON. And what we expected again is just the first name. So this is an object, first name. I'm just going to fill in these fields. So here I did not reuse this schema that we have defined for a user. And the reason for that is that we don't pass an ID, and that schema has an ID field. You can also create another schema, user without ID or something like that, or create user request. That's also a very common pattern. But I think in this case, since we're just dealing with a small API, it doesn't make sense to create so many schemas. So now the next thing on our agenda is to be able to edit the contact. And this is going to be also very similar to the post request. I'm just going to duplicate this, but the difference here is that it's going to be a put request, which is commonly used when you're editing data. And here we need to pass in what contact we want to actually change. So there's going to be an ID in the URL, the contact ID, and the rest just stays the same. So in the body, we're going to send the new fields that overwrite the old data, and then we receive the new contact. And of course, we want to be able to delete a contact. And for that, I'm just going to duplicate this again. And this is going to be a delete operation. And it's going to be contacts/ID. And the body actually, let's go back to the design tab. and we don't need anything inside the body. So let's just do none. Perfect. So now that we have designed our whole API, it's time to export it as an OpenAPI specification JSON file. So let's just go to advanced, and here you're going to see there is an export project data button, and here we can choose Swagger. Swagger is actually the previous name of OpenAPI, and then you can just click on export. So I'm just going to call this API specification, and I'm going to save this in a project folder that I have already created, and click on export now. So here I have the project open, and we have a new file, API specification. And when you open it, you're going to see everything that we just created, including, of course, the endpoints, the types, and basically everything that we created. And creating this by hand would have been actually a lot of struggle. It's a very tedious job, so it's way easier to do it this way. So now that we have this OpenAPI specification, what we can do is to generate the backend code for us. So in order to generate the backend, we can use a command line tool, and that's called Swagger CodeGen. And it goes like this: Swagger CodeGen, and then you define which language you want. So here we're going to be using Node.js server, but you can also pass in Ruby or Java. Actually, everything is detailed in the documentation of the tool. And then you're going to pass in the name of this file, the OpenAPI specification, so API specification.json. And the output, I'm going to call this server. Click on enter and let the magic happen. Now you're going to see we have a new server folder, which is a JavaScript project, a Node.js project, and it has everything that you need. So here we have our controller. Let me close this for a moment. And you're going to see we have our contacts, get and put and post and delete and everything. And all you need to do as a developer is to come inside this default service and change the data. So here you can, for example, get the data from your database and return it. And the cool thing is that it's already pre-filled with examples. So if I go ahead and start the project, let's go inside the server folder and install the dependencies. And now we can just start the server. So npm run start. And as you can see, the server is running in 8080. So in our API client, I'm just going to select that we are pointing to 8080. So the URL is localhost 8080, and send the request, and you're going to see a response. And this is all from the example code that is generated in our backend. So this is really cool because if you're making the front end yourself and a backend developer is writing the backend, then you don't need to wait for them. You can just use this server instead, and that's really, really cool. So all the endpoints work, and they all return some pretty good values. And if you want to take this a step further, you can also go back to this design tab and provide some example values for every field. So that's an extra step that you can do, and that's also going to be used in the generated code. So that's really, really cool. And another quick tip, if you are tired of switching back and forth between Echo API and Visual Studio Code, you can just install the extension from Echo API. I also know that the team is constantly adding new features, so it's definitely worth using. Now comes the question, how do I actually use this in the front end? And actually, it doesn't matter if you're using a web app or if you have some kind of application, Flutter, React Native, or native. It doesn't matter because you can also generate the client just like we did with server. And the good part about the client is that you don't need to change anything in it. So you get the types generated, the paths, everything is done for you, and you can just get the data and show it to the user. And I actually also made a video. I'm going to put it somewhere here. I don't know if it's on the right or on the left, about how to do this in React with React Query. So it's the same example, and we have a server running in the background, and we get the data and synchronize it with the front end. We also show loading states, success and error states, and all works flawlessly. It's a really, really cool project. If you want to get started in web development, go check it out. I'm going to put a link to it. And especially if you're into front-end development, then you definitely want to check out my other videos as well. Thanks for watching again, and see you in the next video.